Hi, I'm Ross Wimer. I'm a design partner at Skidmore, Merrill in the Chicago office, and I'm here with Keith Besserud, who runs our Black Box group, and we're both happy to be part of the AEC Online Expo. And we thought it was a great opportunity to talk a little bit about some of the new technology we're using, some of the new software, and the way we work, at least for a part of this office in Chicago, and some of the ways we're trying to push innovation and push our design in a new direction. And in order to do that, we've had to do some pretty unusual things, right, Keith?
Yeah. The Black Box group got started about 2 years ago, and so we've been working to try and introduce some of the newer technologies that we became aware of in some of our studies into the office, into the studios, and especially to the designers in the office, and to help them understand how these different ideas can integrate into the studio work and generate projects in new ways, and look at being able to generate new results for projects, to use the technology to help us find new things that we might not have found otherwise.
Yeah, and one of the things that you may not be aware of, that Skidmore, Merrill is a large firm, but each office has a slightly different structure. But here in Chicago, we have both architects and engineers, as well as urban planners and so on. But what we're doing these days, though, is integrating all of the disciplines through the software. So our engineers, for instance, are using a three-dimensional model to test out structural loading, for instance, and our environmental engineers can use the same model to test how the building performs environmentally. So we're able to work, between architects and engineers in a fluid way through this medium of the technology, and that's where Black Box comes in, because Black Box helps us. It helps all the disciplines push what they're doing and push their ability to understand this data that's being created.
So along that line, I think that there's sort of two things that within Black Box that we rely on most frequently. One of which is the concept of parametric modeling, which is fairly new to the industry, and the second is simulation tools that are available now, that have become available fairly recently, just in the last several years. So whether it's structural design, where they have simulation tools to help them understand the way forces are moving through buildings, and visualization tools to help architects who are visually minded to be able to actually see that output and to understand that in sort of a fundamentally more profound way. I think those sorts of tools are having a big impact on the way that we're able to design, by being able to understand those concepts better. So the simulation tools and the parametric modeling. In the parametric modeling, we have the ability to sort of quickly make changes to models and have them update in all of their complexity in a much more effective way. So we can build in relationships and different sort of performative ideas. So whether we're trying to make the building respond very nicely to solar issues, or to a structural concept, or to view issues, or to economics, or any of the criteria that typically work their way into a design process and evaluation of a design, we can actually use the computer and the parametric software to create explicit relationships, so that we say, well, if we want to study making a change to the building, then we know that if we've got the rules that address the solar orientation, then the model will update and still respect those goals that we laid out, even though we've modified the form in some way. So it allows us to be much more sort of deliberate about the way we explore ideas, and then our ability to iterate through multiple different variations on a concept very quickly.
Now, one of the things that's interesting for me about this is that it forces us to work in a different way in terms of the way we design. In the past, it used to be, the design partner would do a sketch, and you'd give it to the studio, and the studio would follow his sketch and try to develop the idea of one person. So the sort of pyramid structure of the way the design was developed, came from the top down. Now, what we're talking about is a way of designing using the software that's more experimental, and we're testing ideas, and there are a lot of failures too. And sometimes we learn from the failures, but it's a totally different process where sort of the bottom part of the pyramid is creating a lot of information, a lot of data, and a lot of experiments really in form.
Right.
And then it becomes an editing job or a refinement of those ideas that allows us to create the final product in terms of the architecture. But it demands a level of confidence and a level of a different sort of approach to designing other than the way we used to work in the past, where you had an idea of what you wanted to look like, and the goal was to get the studio to kind of complete that vision. Now we're actually trying to develop a vision out of data.
Right.
We're trying to create a vision out of a form that the computer can create, and then adjust that form to a site or adjust that form to an approach that the client's going to get excited about. So,
right.
So I think it's a very interesting new direction in the way we design here.
Yeah, and it requires sort of a leap of faith in terms of an explorational process, because you don't have that sort of end goal in mind. You have a general sense of what you want the project to be about, but then you start sort of having low-level, maybe rules in a way that you then allow to interact with each other and create something. And sort of as an example of that is this Voronoi diagram idea, and we're going to talk with some people a little bit later about this in more detail. But this design of perforations is the result of a logic. Actually, it's not a result of a sort of a predefined idea about what this might look like. There's a system of rules within a script that generates these perforations, and it takes in inputs and uses that information in order to create a geometry. And by playing with the rules in the script, then you can generate a number of completely different ideas or results of how that would look. So I think that is, as you said, is a fundamentally different way of approaching design. I think that wasn't really possible before we had these sort of technologies available to us, because of the ability to use scripts to drive geometry within a virtual environment. As opposed to we're very comfortable in a physical modeling environment, and we still do this. This is still quite valuable to the design process. But having the ability to take something physical and make it digital, make it virtual, and to be able to play with it in the computer allows us to explore ideas very quickly that might become more difficult in sort of a physical environment. So.
All right. Well, that's good. I mean, with that, maybe we'll go out into the studio, into our laboratory, and we'll talk to some of the people who are actually working on these projects and using the technology now.
Justin's going to talk us through a little bit about a project that he's been working on for a roof structure for a transit hub project in China. So why don't you show us what you've been working on there, Justin?
Okay. So currently I'm working on a roof structure for Tanggu high-speed rail station. The basic concept of this was a spiral design that acts like a shell over the entire transit hub space. The basic math of this thing is a spiral shape, and it also has some influence from Mitchell frames, which are a naturally very strong structure. And we started out with this circular shape based on a series of spirals that we then map into the site, responding to various programmatic conditions, and also to fit into the site space. This is a plan view of that. And another shot of it in the site. And the interior view.